Just to make sure that it was right to JSON.
Yeah, it was the save part of player.
Oh, to see if you could use a print writer, right?
Print stream.
Print stream? Okay, yeah, that'll work. Okay, so right now, we built it already, didn't we? Yeah, this is our output. So is that from, we still have it running. So was this, where did we do that? Was that in driver? Add player, where's our save?
It's in player.
Here it is. Display to user, the cave to JSON, export to JSON. So that's already happening, right? So we're getting it written out to the user. We just need to write it to a file. And then when we restart the cave, man, somewhere we need to have like a help. We need to probably put a help function in today to remember what our commands are. Let's see, what are my commands? My commands are create exit. Name of the exit is up, down, the loft. New room is created, so now I should be able to go up to that room, and then down. I should be able to do save, and now that's saying saving the cave and printing this out. So that's what gets displayed to me. So I think we last time went in and didn't we pasted that into our code and made sure it still read it in. Had I undone that, or we still have the? Oh, I already had the loft. So I have two lofts now. This is terrible. Yeah, I already have up in there. I just created a second up, which actually became, it probably shouldn't have been allowed, but right in our game right now it allows it. All right, so we want to be able to automatically do that. So I should be able to do a create exit down and then another one up, and that's the basement, let's say, and that should then get saved out to the file. So when we save, rather than spitting it to the screen, we want it to overwrite the file that was used to create this guy, right? Okay, so we probably want to do this inside of Cave Parser. So in Cave Parser, we built in the ability for this guy to get JSON. Well, that's that side of it. What do we do in player here? For save, we called the cave.toJSON. So our cave has a oh, there it is, has this guy. And then we know how to display that. How did we display it to the user? We said export to JSON. There we go. So a JSON object knows how to export itself to JSON. That's JSON object here. And we have export to JSON, which ultimately gives us a string. And we want to take that string and we want to overwrite the file that we currently have, right? Okay, so, and I said you should use a print stream. All right, so let's go to the documentation for print stream. I already have it open. I don't have it open. It's going to take us to a funny place. All right, now I'll just go to java.io here, where print stream lives. Or print stream. Print stream, good enough. Okay, and we can build a print stream using the file name. All right, so we should probably use the same file name that was originally, if we're saving it to the same file name. So let's go ahead and teach a cave how to save itself using a print stream. So let's go in here. We'll go to a cave. A cave knows about, it currently is not storing that file name, so we probably should go ahead and store that file name from our cave. Because right now when we build our cave, we're creating the cave parser using that file name. But we're not actually storing the file name ourselves. So let's go ahead and do a private string file name. This is the file name associated with this cave, and we'll say this dot file name is equal to file name. So now we've held on to that piece of information. Now we can go into, what was it, cave parser. And remember this special stuff we had to do to get the user file name. So this guy right here, we had to build the full path to that file name. So I'm going to steal that here. We'll go back into our cave. And then down here, where we said that returns, oh, we want to do this in, let's teach this guy how to save. So we'll just do this. We'll write a new function in here. Public void save to file. All right, and this guy is going to create a print stream output is equal to a new print stream built using that string, the full string of where our file name is. And our file name is this dot file name. Okay. And then we're going to have to import java.io.printstream so we have access to that dude. All right, and it's telling us that this could throw an exception here, so we can either deal with it up here by passing the buck or just deal with it locally. We'll just put this inside of a try catch. Will this embed it in a try catch for me? Woot. Okay. But now let's make it look like a human being wrote it. Here we go. Okay. So that'll create our output stream. Now let's go and look and see what abilities we have in output in print streams rather. So print streams have the ability to print stuff out. So this prints a string, and we happen to have a string that we want to print. So this guy's going to take in a string that we intend to print. And we can actually get that string from our current. Yeah, let's do that. We'll ask our cave to go ahead and convert itself to JSON. And then tell that guy to get the string. So where's our save? Here's our save. So we have our output file. And we'll say output dot. We can do print. We don't have to have a carriage return in there. And we're going to say this dot to JSON dot, was it to, is it not that guy that has the string to write it out? Go back to player real quick. Export to JSON, that guy. Export to JSON, that's my string that I want to write. So we'll do output.print and we'll write that. And then we'll say output.close and that should save it. And it should overwrite the file we have there. So print is for overwriting, and let's go back here and look at the various constructors we have. All right, this guy creates a new print stream without automatic line flushing. All right, so actually this might not write anything out. We might have to do a flush. Let's see what it does. Notice that some of these other ones have a Boolean whether or not it should auto flush. So what ends up happening is we write to this stream, and unless somebody reads from the other stream, it gets stuck in the tube, if you will. All right, so let's give this the old college try. But just in case, I'm going to copy our current. I just do a select all. Clearly. All right, and so let's go ahead and try to put our thing for down, but we need to change our player right now. So instead of displaying this to the user, we'll go ahead and display to the user saved. But what we'll do in the middle is we'll say this dot, well, we have to do cave core to get to the cave, right? Cave core dot the cave dot save to file, and that guy should do the magic of saving it to the file, overwriting the current file with our current JSON. All right, so let's see if we can make that work. So we already have our normal guy there, so let's go ahead and let's create an exit. We'll create an exit down. Return exit is up. This is to the basement. All right, and then we just do save. So if do I have look already in here? Yep, so there's my exit. So I can go down, I'm in the basement. I can go up, I'm out of the basement. So let's do save. Okay, it said it saved the cave. We're not showing them a prompt again. Let's go ahead and run this again, and we have our down. So there's our down, there's our up, so we didn't have to flush. It did get written to the file. Let's go ahead and check that file here quickly. And notice it did overwrite that file as opposed to append to it. So when you open a file for writing like this, if we just print to it, we are printing over whatever was already there. If there was 5,000 lines in here, we would overwrite the 5,000 lines. That's why there was append functions as well, where you can add to the end of the file. That make sense? All right, how did that assignment go? Not good? Not not so good? What problems do we run into? Because kind of the exercise was part of it was reading the documentation, right? So what were some of the challenges we had in doing the assignment?
When I was reading the documentation, I would write it as is, but when I tried to close it up, it kept giving me a exception error, or a file not found exception error.
Okay, so probably because you were doing this. So if we want to recreate that, we can go into, where do we have it in Cave? We have too many files. Do you agree with that? Actually, what the bad part is that Eclipse is a crappy IDE where you have to double click on the file over here rather than just click once to show you the current file. It'd be nice if you could just click once and have it show you the file instead of having a zillion files open up top. So let's go into Cave. So my guess is what you did in your, what is it, save to file. Am I in Cave? Oh, it's up top, isn't it? Right here is this line. you probably didn't do the special stuff to get to where our source directory is. You probably just put in the file name like that. And then when we go to run this, if we hit save, do we have a file in our, we might have cave.json in our other place. Here at the very least, let's do this.
I tried writing it later.
It shouldn't make a difference because you're still writing out to the same file.
You have to refresh it. Like you have to click on the CSC250 page crawler, right click on it, and then go down and refresh or hit F5, and then another file should pop up that says cave.json. It's under importer.
Right there.
And then it popped up under the library, system library.
Oh, because this is in bin. I gotcha. But the important thing for us is that if we read this, let's go ahead and let's add something new. So we'll, was it create exit? Right. Next thing we're doing is adding a help menu for the available commands. So we'll do create exit. So exit name is going to be West. Return is going to be East. This is the dining room. All right, room is created. We'll go ahead and hit save. It saved it, but it saved it into this file here. So if I run this again, I don't have a West. It didn't save it into the file that I meant for it to save it into. It saved it into a different file. Now, so print stream, I think will automatically create a file if one doesn't exist. Is that true? Well, I guess we can test this real quick. Let's go out here to our terminal. Where are we? So if we go in here, the bin, I'm going to remove our star JSON files. So both of those JSON files are now gone from the bin directory. Let's see if it will create one for us. Kind of wish I hadn't just gone back to my whatever. All right, so these guys should be gone now. Oh, he's not gone. Oh, it's right there. Yeah, so it will create it. It's actually kind of handy to have our JSON there instead of in the normal source folder. But then we can't just push the source folder up to GitHub then. So it's not that handy. Yeah, so I don't know how you would have gotten the file not found exception, because if we remove this from here and we run it again, it would give us it wouldn't give us an error. Because it created that file for us. So I guess I'd have to see what you tried to do to give you that that error. Or what other issues did we run into in doing this? Nothing. It was just a little complex.
So print isn't just for like outputting things. So like print in itself, we do system.out. So that like prints it to the screen, but print in itself is just like moving. So in this case, it's moving it from the print stream into the file.
Right, but so what is output? Output is an instance of print stream, right?
Yeah.
So if we go back to the documentation, I go to java.lang, and I go to system, click java.lang, and I go to system, and I go to out. What's out? He's a print stream, and he's a static print stream, so that's why we say the name of the file, system.out. And we're calling that guy's print or that guy's println. And when we create, when that print stream was created, so I'll just jump into that print stream, we used the output stream. Okay, we used the output stream that it was created around. And the output stream is standard output, which is our screen, our console, as opposed to the output stream that will get created here, which is associated with a file name. So system.out.print and in our case output.print are the exact same function. They print to their associated output stream. In this case here, the output stream is the stream associated with our file. In the case of system.out, it's the output stream associated with printing to our screen. Console.out or standard output. Does that make sense? Yeah, so it's not a new kind of animal. It's the same kind of animal. He just has a different variable name. All right, anything else? All right, so let's go ahead and give ourselves a help command here. So this is our if all else fails, assume they want to take an exit. What do we do in the event of a bad exit? Oh, that's not a bad exit. Let's just go north again. Destination room not found. Okay. But we need to make sure that we're giving them a prompt again so that the user can keep working within the cave. So let's go ahead and do that. So after we say saved here, we want to go ahead and do show prompt. Actually, it seems like we do show prompt there, we do show prompt. Can't we just always do show prompt? Regardless of what magic we tried to do in there, can't we just show a prompt? So show prompt always calls itself. We would probably currently have a small bug in there because I think when we create a room, when we enter a room, won't it show the prompt twice? So I think that's going to be in room. We add a player to the room, so where's add player? Right here, so we display the details to the user, which is right here, and then we are showing the prompt to the user again, but we don't need to do that because the prompt automatically gets shown to the user upon the completion of any command. So all show details to the user is going to do is show details to the user. That's it. We're going to rely on our show prompt to re-show the prompt, which is probably more correct. So now we should always get a prompt no matter what we try to do. Clearly. What's the initial problem? Initial problem is that we didn't get to the original room by showing the prompt, right? Kind of have to get the ball rolling there. So here's our cave, And when we add the user to the cave, didn't we find that there was a collapse all? Didn't we discover where it was? Kind of remember, is it out here? Ah, here, collapse all. There, that makes our code a lot easier to navigate now. So here's our add player. So when we add a player to this guy, we add the player to the room, then we say return. But before we do that, that gets a little kind of bad. Who adds the player? Is that in driver? Yeah, I guess probably the best way to do this is just say the player.show prompt, just to get the ball rolling. Yeah, I think that makes the most sense. So there's our initial prompt. So we can go north, goes there, we can go south, go there, we can add an exit. And so what do we need? We need a, oh, we had done a west, but when we saved, and then the comeback will be east. Oh, I need to, oh, what's it? Create exit? West, east, the dining room, save, look, now we have a west, then we have east, we did already save, right? And we still have prompts going, so it seems like we have kind of a functioning dealy flippy, and let's make sure west still stayed there, and it did when we reran. All right, so this is starting to turn pretty legit, right? All right, so let's go ahead and quickly give ourselves a help screen, and then let's start putting monsters and stuff in here, because we need stuff to go around and kill things. Okay, maybe not monsters. Maybe we want to collect treasure first or something. Although monsters to fight seems more fun. You make the decision. We fight monsters or we picking up gold coins? All right, good. I was hoping you were going to say that. Because picking up gold coins seems so boring, right? We'll pick up the gold coins out of the burning carcass of the monsters that we killed. That's where we'll get our coins. Perfect. All right, so let's go back to player and let's give ourselves a help menu. I'm going to put that right at the top. All right, so if they say help, then what we're going to do is we're going to basically print out a menu of commands. So kind of available commands. So this dot current room. Oh wait, hold on, I'm sorry. This dot display to user available commands like this, and then we'll go through our commands. And why don't we go ahead and, for the sake of that code being relatively easy, let's create an array of commands that we can spin through that array. So adding a new command will have us change a whole bunch of code in here. So we'll just create a string array called the commands. And this guy is going to start off, he's going to be, we have what? Help, comma, look, create exit. Save. Or is the exit they want to take a command? Or is that just our catch-all? Like, are we already showing them those possible things? Yeah, I think we leave that off of there. Good enough. And then we can use our little for each loop we learned last time, right? So we can say for string command in the commands. What are we going to do? We're going to say this dot display to user command. Something like that. And then the prompt will automatically get shown. So now if we run this and we type in help, we run this and we type in help down here, we get our available commands. Help, look, create, exit, and save to remind us of what's there. Then we can go back to look. If we really wanted to, we could also throw in the what each of these commands does, but for right now, I think this is sufficient. Okay, so now we're going to have to create another command, and that command is going to be to spawn a monster. All right, so initially our cave is we've kind of come to terms with this idea that we're no longer going to be directly editing JSON, right? The starting point for our cave is just going to be our cave entrance. That's kind of a template for an empty cave. And then we actually build our caves by going into the code and building our cave from there. Make sense? And now that our save is working, this seems to be pretty convenient. Nice little stepping stone for those of you who are interested in the Android thing. A couple of you contacted me to work on that over break, but that'd be kind of a cool little, especially with death matches and monsters in there, right? Walk into a room and all of a sudden you find yourself face to face with a mutant rat or something. Splinter. Right? Isn't that his name? Splinter from Teenage Mutant Ninja Turtles? Yeah. Oh, see, you didn't know. How do you not know about the turtles? That should be a quiz. What are the names of all the turtles? We should know what all the names of the turtles are. We should know what color bandana thingies they were, the masks they wear, and what weapons they use. Right? Donatello, it's purple and he has the bow staff. Leonardo, it's blue and he used the katana blades. Michelangelo, orange, uses the nunchucks. Raphael is red, he uses the sais. And Splinter is the mutant rat dude, he just uses his hands. I think he has a little cane thing, we never used that in the cartoons. Then Shredder, he's the bad guy. He's all about armor and bossing around. Bebop and Rocksteady, right? Am I running out of things that you know about? Yeah. Bebop and Rocksteady were like his dumb minion guys. Bebop was like a mutant pig and Rocksteady was a mutant rhino. Now I'm disappointed in you. It's already disappointed everybody else.
Sorry, I knew more than other people in the class.
Just terrible. There's going to be turtles in our game. I think we just covered that. All right, so we want to go ahead and be able to spawn monsters, which means that we now need to have a new kind of thing that lives in rooms, right? Okay. Right now in our rooms, we have, let's go and look at room real quick. We have a collection of exits. There's a room. Okay, so rooms have a collection of exits. A room has a name. A room right now has a single player in it. Right now we have a single player game. All right, eventually when we do this, move this over to Android, we're going to make this a multiplayer game where people connect to a centralized server. So we can actually, the cave will run in a server and then we'll be working within that server through our game. So we would actually have a collection of players in a room. But right now, it's a single player game. We're just going to have one player in the room. But now we want to have a new kind of dude that is a monster. Make sense? Okay, it's going to be a monster. And monsters are going to initially just have a name. Let's just kind of bring them into creation. Fights aren't going to be so convenient yet. Okay, we're just going to get a thing that is a monster into the room. Usually they're called NPCs in games, non-player characters. But and I suppose we'll do that. We'll create an NPC, and then we might have two different kinds of NPCs. We might have enemy NPCs, and we might have good guy NPCs that we can, like, they're vendors. Maybe buy swords from them and stuff like that. Oh, it's going to be epic textual awesomeness. Is what this is going to be. What's this?
So this is going to get complicated real quick.
You think? None of these individual parts are very complicated, are they? I mean, what's tough right now is that we have this giant cluster of files, most of which we don't have to touch very often. So, like, for instance, all these JSON guys right here, we could put into a folder. Let's see, does Eclipse support that? New. This could be dangerous, but let's try it. Folder name, let's call this JSON objects. Let's call this JSON library. And let's see if we can get all our JSON dudes into that JSON library. Okay. So it appears that everything still works. So we can actually get rid of our simple JSON now, right? We don't use that guy anymore. Okay, and then these are all of our stuff that make up our actual game, but we can create our we can create a new folder for those, and we'll call it game objects. And then we can move cave, cave core, cave parser, exit, player, and room all into game objects. Okay, and then we just have our default package up top, and everything I think still should work. All right, so things are a little bit more organized now. I wouldn't say it's great yet, but it's a little bit better. All right, so we're going to create a new kind of dude, and this is going to be inside of our game objects. And we're going to call this, what, an NPC we said? Okay, so we're going to say this is an NPC. And notice that these guys now are all in this package called game objects. So when we created that group, these all became part of that, that package called game objects. Packages in Java are basically names of directories. All right, and then we have our default package, but since all these guys are public, they're accessible from within other packages. Okay, if I had these as protected classes, remember I said a while ago that protected kind of had some additional meanings that we never talked about? That means it would only be accessible within the package that they belong. Okay, but by making them public, which is what we commonly do, we have access to them across all of our packages, so we're able to give us this organization like this, and everything still kind of works. Okay, and then we can leave our cave JSON. That's not hurting anybody there. Okay, so we have our new monster, and let's go ahead and just close all from there. Yes, save that. Let's just go back in. All right, things seem a little bit more organized now. So what's a monster going to be? It's actually, we're going to model monster kind of after exit. Okay. Oh, notice here that we did have to import some stuff from our JSON number variable from our JSON library so that we had access to that stuff in here, because we're actually, think of this like a variable environment where when we are inside of game objects and we need access to something that's inside of JSON library, those guys are out of scope. So we would need to import something from a local package, which we have access to, called JSON library, so that we have direct access to JSON number variable. Okay? Okay, so we're going to model our NPC after an exit. So an NPC is going to have a name initially. We'll keep him pretty simple. So he'll have a private string name. All right. And notice that exits can be built using JSON objects. So I'm going to go ahead and I'm just going to copy that guy right now. Okay. Now really let's keep it as destination ID. All right, so a NPC is also going to have a destination ID, or maybe we call it a spawn room ID. So that's the room that monster should initially spawn in, where you should initially show up. Later on, we're going to give our monsters a mind of their own and have them start wandering from room to room to room. Okay, but initially, our monsters start in a room and stay in that room, but we need to be able to tell them where they go. See, won't it be kind of interesting if we're standing there in a room and the shredder runs in? Bebop and Rocksteady in tow. I think I had told you when we first started writing this, when I was a lot younger, I wrote a MUD, one of those Texas Instrument graphing calculators. I think I was nine or 10, something like that. And so that was the only computer I had to program on. And so I wrote a MUD on there, and I had one of my NPCs was a wood chipper. Did I tell you about this? It would randomly travel from room to room to room. So sometimes you were in a room and a wood chipper would come in, and that wood chipper took over the room. But so you got sucked into it. Obviously, bad things happen if you get sucked into a wood chipper, but then you would keep moving with the wood chipper. So as you're trying to escape while you're getting just shredded, the exits kept changing. So you had to like quickly try to type in the exit before the next heartbeat, where it moved to a new room and the exits all changed, and then it just would spit you out somewhere on the map. Hurt, and so yeah, that's probably why I turned out the way I did. Something screws loose. All right, so to build an NPC, we're going to use a JSON object. All right, and that JSON object is going to contain stuff for name and spawn ID, spawn room ID. All right, and that's going to be a spawn room ID like that. All right, so we're just making assumptions of what that JSON object will look like. All right, now we need to go in here. We need to be able to build a JSON object out of an NPC. We need to be able to get the name. We need to be able to get the spawn ID. So here, let's just steal this and we'll generate the getters and setters. All right, so we'll have a name, then we'll have room or spawn room ID. That's that guy. All right, so now an NPC knows how to turn themselves back in to a JSON object. Okay, let's see. We are going to need to be able to create an an NPC using a name and a spawn room ID so that when we add an NPC to a room, we're not going to be giving it the JSON. We're going to be giving it the name as well as the room that it's currently in, the room that we want to spawn it in. So right now we're going to probably go into the room and we're going to say spawn and then what's the name of the NPC? Boom. And the NPC will spawn right there. Later on, we might have IDs for NPCs in case we want to spawn an initial rat, let's say, and then we want to put the same kind of rat in multiple rooms in our thing. That way, maybe all of those rats act the same. We're going to have some sort of mechanism for handling, the rats all have 10 hit points and have a bite attack and that kind of stuff. That way, you don't spawn 1,000 individual rat objects. Instead, it's one framework, one class that represents all rats in your dungeon, except for Splinter. Splinter's a super rat. So, in any case, we're going to have a second constructor here so that we can build an NPC. So that's going to be our public NPC. This guy will take in a string name and an int spawn room ID. And we'll set this dot name equal to name and this dot spawn room ID equal to spawn room ID. All right, so we have two different ways we can build NPCs, either through a JSON object, which will get created with our rooms, with our cave parser, or through our when we're spawning a NPC in a room, calling this constructor directly. Okay, so for starters, let's just get the spawning a guy in the room part working now that we have an NPC. So we need to go ahead and let's teach this guy how to at least give us his room IDs. So source, generate getters and setters. Let's get the name and let's also get the spawn room ID. So we'll just give ourselves those two functions so we have access to them. All right, now who has NPCs? Who has NPCs? Rooms have NPCs. So we're going to add a new element to our room. So private NPC array, the NPCs. It's going to be this. And then we're going to have to fill up our exits, or our NPCs, in a similar way to how we filled in our fill in our NPCs in a similar way to how we filled in our exits. So I'm just going to steal all this code. We're going to say get the NPCs. So we'll reuse our variable AV. And that's going to be get NPCs. And then we're going to say the NPCs is a new NPC array. Then we'll go ahead and reuse our variable called the objects and set it equal to the value associated with AV. Then we'll spin through all those objects and set the NPCs at bucket I equal to a new NPC given that JSON object. Okay, so we're going to fill a room up with an additional list, an additional array of NPCs that may live in a room. Okay, but by default, there's nothing in there. Okay, so that array would come out as the empty array, and we'd have nothing in that room. because I'm pretty sure we can look at JSON array variables. So I kind of remember, didn't we say that if there wasn't that we would have at least one thing in the array? So that presumes that there is, in order to see the impact that has, that would say that every room would have to have at least one NPC in it, and that is not our case here. So JSON array variable, let's go in there. Well, I think we might be okay because it automatically holds up to 50 objects. That's our limitation on our JSON array. Current size is 0. When we return the value, we'll return, yeah, an empty guy. I think we'll be okay. I don't think we'll have to do anything special. But if it crashes, we'll investigate more. Okay, so we'll try to grab all of our NPCs, store them inside of this array of NPCs. When we build a brand new room, we set its exits to the empty array, and we'll also set the NPCs equal to a new NPC array that's empty. Okay. Fantasy football team lost. Killing me, Packers. Let's see. Okay, so that's for our NPCs. When we convert ourselves back to JSON in a room, what did we do? Well, we got everything we had before. Here's us getting our exits. Now we also need to go ahead and get our NPCs. So we'll steal the exit code, get the NPCs. Let's go ahead and label this guy too. Get the exits. So we'll get a JSON array variable, the NPCs. We're going to name this guy NPCs for NPC n in the NPCs. We'll say the NPCs.addJSON object n.get JSON object, because every single NPC knows how to convert themselves into a JSON object. We already wrote that function. And then we'll go ahead and add to our object the NPCs and return our object. All right, so when we ask a room to convert itself back to JSON, back to a JSON object now, what it will do is it will build everything it used to build as well as an additional JSON array variable of NPCs. Okay? All this stuff should be fine. Removing a player shouldn't change. Take an exit shouldn't change. Display details to users will change because now we need to also show them who else is in the room. We're currently showing them possible exits. Now we want to also, so this shows the exits, followed by show the NPCs. So let's just steal this code. Other inhabitants. So we'll go through all the NPCs. We'll display to the user each NPC name. All right. So for some of them, there will be nothing in there. For all of our rooms, initially, there'll be nothing in there. All right. Then we'll add the player. Nothing to change there. Adding exit, nothing to change there. We are going to have to write add NPC to a room. So let's steal this code. we'll add NPC. And this guy's going to take in just the name. And the reason it just takes in the name, it knows the room that this guy's being added to. It's this room, the room we're currently standing in. All right, so we're going to create a new NPC array called temp NPCs. And this is going to be a new array of NPCs that is one larger than my current array of NPCs. We'll go through all of the NPCs, copying each one over to my temporary array of NPCs. Then we'll put our brand new NPC in here. So temp NPCs at bucket temp NPCs dot length -1, the last legal bucket inside of temp NPCs, is going to equal a new NPC given this name and given this dot ID. That is the ID of this room, the spawn room ID for that guy. All right, this is why we had to write that second version of the constructor for NPC, so that while our program is running, we could add an NPC to the room, and he only gets converted to the JSON version of that when we hit save. Make sense? All right, and then finally, we'll set the NPCs equal to temp NPCs. So we overwrite the old version of NPCs with our new one NPC larger version of NPCs. Okay. Perfect. So that's that. And when we export this guy to JSON, we get all the NPCs and add that. When we build this guy from JSON, we get the NPCs. Okay. And run this. All right. Cave room at 31. Is that because we have an empty? Oh, I bet you. If we want this to work right out of the box, what happens if we ask a JSON object for something that does? The reason we're getting a null pointer exception is because we're trying to read in the value of NPCs, and there isn't a variable for NPCs in our JSON right now. We haven't put one in there yet. So we could actually fix this inside of room. So when we try to get, right now, we don't have the problem because every one of our rooms has an exit in it. Make sense? Our starter cave had an exit in it, but the reality is our starter cave probably shouldn't. We should start off with just a room with no exits and then have exits grow from there. So what we really should do is say something like, get variable for name is going to be that. Let's look at JSON object get variable for name. I want to see under what circumstances does it give us a null. Yeah, here's our null. If it goes through there and never finds that variable with the given name, it returns us a null. And we tried to do stuff with that guy. So given that, can we create an empty JSON array variable? We can. So we can fake it. That's good. So we'll go ahead and fix this for exits as well, so we won't have this problem in the future. So inside room, we'll try to get our JSON array variable. I wonder if it's if AV is equal to null, if we do not currently have an array variable, what will we do? We're going to say AV is equal to a new JSON array variable given its name, which is going to be exits. All right, so that guy will go ahead and create a blank exit array for us as our starting point, but only if we didn't actually get one from the JSON object. Similarly, we'll do the exact same thing down here. If AV is equal to null, we're going to create another one for NPCs. So we're always working with at least something. So before we always had exits, so we never had this issue. All right, so now it runs. Other inhabitants, we have nothing in there. So nothing to worry about. We should now be able to write the code to add an inhabitant to a room. We're going to call it add NPC, or is it create NPC? Yeah, to match our create exit. So let's go into player and close that guy. All right, so we'll add. Just keep adding it to the end. Create NPC. Well, let's actually put that right before the. We'll put all our create stuff right next to each other. All right, so now we should have that additional create NPC command. We don't have to change our help guy at all because he's always going to be reading off that array of commands. All right, but now we do need to steal our, well, we probably want to just build it from scratch. Let's just steal it and we'll just cut everything else out that we don't need. Else, if they say create NPC, we're going to say creating NPC. Please enter the name of the NPC. Give them a prompt. We'll read in the name. And then we're going to go ahead and set the NPC name equal to whatever the user response is. We actually don't need anything else here from the user. So with creating rooms, we had to ask several questions. We just needed one question. All right, so in this case, we need to get the player's current room. That is our room. All right, so that's going to be actually pretty easy. So we don't even, well, we'll keep it inside of NPC name just for clarity's sake. So we'll get rid of that. So now add the NPC to the current room. This dot current room dot add NPC name, and then we can say new NPC created. Okay, and maybe after we do that, well, we could tell them to look. I guess for right now, let's just leave it like that. So now we'll go ahead and we'll type in help. We should. You would think they would put. So we'll type in help. We see create NPC. All right. Please enter the name of the NPC. We'll say a rat. New NPC was created. I say look. Other inhabitants in this room. We now have a rat. Okay. Perfect. So now. We want to be able to kill the rat, so we're gonna give a very simplified version of mass killing to our player. So we need to be able to. We probably want to be able to remove an NPC as well. That would be a very good homework assignment. Pretty easy as well. So just saying it out loud, if I wanted to remove an NPC from a room, if I wanted to add the command called remove NPC, what would we do? We would display all of the NPCs that are currently in this room, probably with maybe here's NPC 0, here's NPC 1, here's NPC 2, so on and so forth. Pick the one that you want to remove. So they put in a 0, a 1, or a 2, whatever the index is. And then you go in and remove that NPC from the room. So you'll remove from bucket 1 that NPC if that's the one they chose. And now the NPC is gone. So what does it mean to remove an NPC from a room? It means creating a brand new array of NPCs that's one smaller than the current one, copying everything from that array of NPCs, or everything from the original NPCs, except for the guy you wanted to remove, and then overwrite the original with the new one. From that point forward, you no longer have that NPC. So that'll be your homework assignment, but let's go ahead and give ourselves the ability. Actually, let's test save real quick now that we have a rat in the room. So we'll hit save. We save the cave. Let's run it again. Ruh-roh. String index out of bounds. Is that in our cave parser? Let's look at our cave JSON here. Okay, so there's NPCs. Name is rat. Spawn ID is 0. Oh, we never actually map him to the room that he should be in. And on top of that, we have now mixed our rooms with our NPCs. When we brought a room into our cave parser, we built a cave. Cave asked for the start room ID. Then it said, let's get all the rooms. So it grabbed the rooms. Then it built the rooms. Get value. We created the room with that guy. So that takes us into our room. All right. Well, we're going to have to fix this next time, so I won't give you a homework assignment then, since this is not in condition. And now we've broken our JSON because we wrote something bad out to it. This is not the correct form of JSON. Our exits right here have all of our exits. But then we get to our NPCs, which looks right on the surface, but inside of our NPCs, we have yeah, actually that doesn't look incorrect. So we're not reading in our NPCs correctly. So we'll fix that next time and talk about the final. Sorry that I didn't give you a homework assignment. Are you upset? All right, I'll see everybody on Thursday.